It has been a while since I have updated on Project Printurd, so here we go. I've made quite a few changes. I haven't documented all of it. I kind of wanted to see where I ended up, and now I don't feel like going back and redoing it all. But I'll still talk about what I did do. So the first thing was that the extruder was just garbage. So I had another hot end that I put on here, and I turned it into a Bowden system. So I got a extruder and installed that. This is just a cheap Anycubic one that I get off of Amazon. I think they're $15. They work well. I've used several of them. So I coupled that to this. I had to reprint all of my mounts for my fan and such. Had to move my X-axis limit switch, reprinted a mount for that. That all works good. So my extruder works great now. It doesn't jam up on me all the time. My part detail quality is really good. It's kind of hard to see. I can't get this camera to focus. So that fixed that problem. I just had a junky extruder. But what I do still deal with is Z-banding really badly. And I was fighting that before, and I thought, well, it's either my linear bearings, which feel kind of rough, or my lead screw. And I thought it was my lead screw. So, other than that, my portholes look good. My overhangs are not too bad. I had a few slicing issues with this one, but the extruder definitely fixed a lot of problems. So my lead screw, what I did was I found that on McMaster Car's website and found the nut for it, and I basically imported that CAD model for that nut, added it to my mount, integrated it, printed that off, and I made my own new nut for that and mounted that. That helped, but it really didn't solve the problem. It still seemed like the banding exactly matches the same pitch of the lead screw. So, all right. So I dug through my pile of stuff. I had this really big ball screw that I was going to try to install on here, which was way too big. It wasn't really going to work well, but I was going to make it work because I wanted to see, is it really the lead screw or not? I finally found, I don't have a lot of lead screws, but I finally found this little one. It's not really made for heavy weight. It's got this plastic nut on it. I looked it up. It's rated for a few pounds, really. But what I did was I added counterweight. I just wrapped a belt around here, and I've got a pulley and some aluminum blocks to counterweight this, to hold that up more, just so that this lead screw, I wanted to see if the lead screw would really fix the problem. So reprinted a new coupler for that, remounted my motor, got all that done, and it does, actually. I've got these calibration cubes from before and after, and yeah, come on, light. There we go. So the one on top is my part before. Boy, this was so easy in rehearsal. Yeah, anyway. Okay, so let's try this angle. Close enough. You can see that the top one, the Z-banding, is still pretty bad, and it exactly matches the pitch of the lead screw. And the bottom one is with that new lead screw. Much better. It actually improved quite a bit. It still has some Z-banding, so I dug in some more, and oh, instant cat. Hi, kitty. So dug in a little bit more, and I realized without the lead screw, just moving this by hand, that these linear bearings, I already had one fail before I even put all this together and had to replace it. And so these are binding up. I pulled them apart, lubricated them, cleaned everything up, and come here, kitty. Come on. Kitty just got fixed, and so she's a little cuddly, more than usual. So, come here. There we go. All right, so lost my thought. So these bearings are bad as well. So those, if I continue on with this project, I'm going to have to replace both of those as well to put something better on. This linear bearing block here that I added for the X-axis works really well. I've got a few more parts and pieces around, so I could add a couple more linear bearings to this and improve that, I think, because I really believe I've replaced everything else. It's got to be the linear bearings. And I did adjust the mount and the angle and such. So here's where this project is the total summation is you can't polish a turd. I started with a bad printer, and I tried to make everything work as much as I could. My Y-axis bearings still seem to be good. My motors, I'm still using all my original motors. Those are good. I had already replaced the ramps Arduino combo before this happened, before I did all this work, so that was already replaced. My lead screw is bad, so I'm going to have to put a real lead screw on there. I think my little bearings inside here are still good. So out of all the parts that I had that I'm still originally using are my motors and one set of linear bearings. Everything else is either been replaced or going to have to be replaced. So at some point, I'm actually just building a printer, not rebuilding an old printer. I am building a new printer. Now I've built 2 bad printers, and so I'm finally building a 3rd good one. So as much as I wanted to make this be a fully functional printer when I'm done, I've got another one that I need to build for my cosplay props. It's a bigger bed one. I've got to get started on that one. So I think I may just set this one off to the side unless I get really irritated and just go on Amazon and buy a bunch of parts. I'm not sure. Still thinking about it. But that is the summation of where I'm at with this, is that you can't polish a turd. I tried. I learned a whole lot in this project. I learned a great amount about using 3D CAD modeling software and printing those parts out and design implementation. I learned a lot. So this was really a great project. Hey, I learned how to strain relief and cable manage. Everybody should be proud of me. So unless I don't know, Christmas is in 2 days. We'll see what I get for Christmas, and we'll go from there. But that is probably my last update on this little guy. This may be the end of it. We'll see. I can never give up on things very easily, which is why I started this. But that's where I'm at.